Now for this circuit I want to find the current Ix. This is a control current for this current controlled current device. Now I will use source conversion technique, and it looks that there is a voltage source here and a series resistance, but I cannot convert this into a current source and a parallel resistance because this is the current, the control current of this one, and if I change, the current will change, so I won't change it. What I will do, I will change this part. So, and we are after this current anyway, the Ix, the control current here. So I will leave this as it is. So 24 ohms here, 12 volts here, and then 30 ohms there, 60 ohms here, and it will become a series resistance and a voltage source. So series resistance will be the same, 10 ohms, and the voltage source, of course in dependent voltage source, that will be, the value will be, the polarity is like that because current is in this direction upwards. The value will be 10 times 0.7 Ix, so that will be 7 Ix. So that's the value of the voltage source. Now we have 60 and 10, these two added, so 12 volts there plus minus, and that's 24 ohms there, 30 ohms there, and this is 70 ohms here, and I have my plus minus 7 Ix like that. So what now I want to do is I will convert this voltage source and this 70 ohms resistance into a current source and a parallel resistance. So I will do that. So this part stays the same, 24 ohms, 12 volts, and this one was 30 ohms there. So that's now 70 here, so 30 ohms, 70 ohms, and of course the current source value now will become 7 divided by 70, so that will be 0.1 Ix. Our control current Ix is still untouched, it's intact, so that can stay the same because everything from this node, nothing from this node is changing on this side anyway. So here it is still 12 volts, still 24 ohms there. Now I can find the parallel combination here, which will be 70 and 30 parallel, so 70 times 30 over 70 plus 30, which is 100, that gives me 21, so 21 ohms there, and then this one which is upwards 0.1 Ix. So everything is like that. Now what I will do again, I will convert this into a series resistance and a voltage source, dependent voltage source, and I will end up getting a series circuit. So it's looking good now. So 12 volts there, this one is 24 ohms, this one is 21 ohms, and the voltage source will be plus minus, and the value will be 0.1 times 21, so that's 2.1 Ix, like that. So this is Ix, it's still intact, nothing has been changed in this side. So Ix, the value will be, of course, this polarity is plus minus here, this one is in opposition, so current is going in this direction, so 12 minus 2.1 Ix divided by sum of the resistances, which is 24 plus 21, so that's 45, so I will write 45 Ix there, and this is now 12 here minus 2.1 Ix, so basically 47.1 Ix is equal to 12, so Ix is 12 over 47.1 amps, that is the value of the current.